Alright, so let's do a quick roll call. We have Praneet, Saranya, Anjani, Ritika, Savya and Riya. And here in the classroom we have Daivik. So we have few more kids we are waiting for. So what we'll do is, we will quickly look at what is our plan for today. So let me circle the area where you see reflection. Okay. And the reflection is a little above this one. Did I cover the area where you guys are seeing reflection now? Okay, so except this part of the board, I'll be writing in every possible corner of the board, but this part is excluded. Alright, so we have Varun and Dhanvin as well now. So, while we're waiting for everybody else to join, let's look at what all did we talk about yesterday. Who all remembers what we talked about yesterday?
Exponential, radical, and rational equation.
Okay. Riya, Dhanvin, Varun, anybody want to share? Savya, what did we cover yesterday?
We learned about radical expressions, absolute value expressions, and radical expressions.
Okay, so small correction. It was not expression, it was equation. Yeah. So we were dealing with equation. So basically we talked about the basic concepts around what is a radical equation, what is a rational equation, and then what is an absolute value equation. So Sahit. So, but I mean that's the premise of what we wanted to cover this week. So we talked about I would say absolute value equation in depth. We looked at many options. We tried solving multiple problems, and we touched upon the radical equation. Hello, Tanu. Can everybody hear me okay before I move on? Okay. So today primarily we are going to talk about rational equation. We'll go back to radical equation one more time, and then we'll talk about what do you mean by extraneous solutions. So there are three things that we are going to cover. Any doubts so far? And somebody must be laughing behind the camera that if you have not taught anything so far, why there will be a doubt? So let's create some doubt for ourselves. Okay. So Tanu, I mean, since you were not in the class yesterday, I have uploaded the video of the yesterday's class. I'm not sure if you got a chance to go through it or not. But just to give a quick background of what we plan to cover this week, these are the three things. Radical equation, rational equation, and absolute value equation. Though these names sound little loaded, but they are not. Radical equation is something where you have an equation where you have something with a radical symbol. So if I have something like this to solve, this qualifies to be called a radical equation because you have a radical symbol. And we'll come back to this because we have some more parts of it to be covered today. So you don't have to rely on what we covered yesterday. We'll come back to this again. When we talk about absolute value equation, this is where we are talking about something interesting that comes our way. Why? I'm dealing with 8 there. So here, these two bars that you see, the vertical lines, this is called mod, another way, or this is what qualifies this equation to be called the absolute value equation. And these bars make us immune to the sign. So here, this x plus 7 could become 15 or minus 15. Both when you put a bar around it, it results in the same value. Basically, you become immune to the sign that you see next to it. Okay? And Just try going through it, the video of yesterday's class, Thanu. I mean, because I think you were not in the class yesterday. And if there's any doubt, catch hold of me in the next class. Yeah? Alright. So, we'll not go to absolute value equation for today. We will focus more on radical equation, rational equation, and there's one more thing that is called extraneous solution, which is more with respect to the radical equation. That's what we will talk through. Okay? So that's why we'll come back to this one. We'll muddle the water a little bit more today. Alright? So before we go to this one, let's come back to something that we did not cover, which I promised that we'll cover yesterday. Rational equation. When you talk about rational equation, I'm assuming everybody is on board with respect to understanding of what is rational equation. This is a natural number, this is a rational number. When you have something written in the form of a rational, like in the form of a fraction, that's what is also known as rational number. So, when you relate that to the rational equation, you are saying that I have an equation which is written in the form of a rational number. When you are trying to solve this, you are essentially trying to solve a rational equation. While it might look similar to what you have seen in the past, but life is not as easy as we want it to be. So this might become complicated also. Now this gives a feeling of a more loaded term called rational equation, right? You see that you have some expression within the numerator and the denominator as well, as representing or being analogous to a rational number, and you have an equal to sign, so that this is an equation. That's why we call it a rational equation, and we will deal with that. So this initial onboarding with respect to what is a rational equation, that is clear for everybody, right? Can I assume that? Okay. Saranya, Shravya, Riya, everybody okay? Okay. Okay. Dhanven, Varun, Arush, everybody okay? Tanu was very quick to give the thumbs up so that no, I don't call out her name. Sahit and Arush okay? Okay. Now let's muddy the water a little bit more. If I asked you guys to solve this rational equation 3 by x minus 9 equal to 18, can everybody solve it real quick? You need a pen?
This one works, it's just full.
Can everybody try it once? I know this is an easy one, but just to do the jump start. Is everybody trying? Hey Vishal. So Vishal, we started with rational equation that we did not cover yesterday. So we just talked about the basic definition of it, which we had done yesterday as well. So I have just given one sample problem that I want you guys to do the jump start with, and then we'll go into more interesting problems that we'll end up dealing with. Okay? So here with this rational equation, I'm saying solve it for x. And we have exactly 2 minutes. I'll be a little stingy with the time this time. Hi Dhanushree. So we are trying to solve one simple rational equation, and then I will make life a little difficult for you guys. You got the answer?
Yeah.
How much it is?
55/6.
Okay. Okay.
Also about 55 over 6.
You all wrote 50, I wrote 6. Shravya, Riya, Dhanvin, Praneet. Yep. Okay, Ritika. Louder, beta.
I got the same.
Same answer, 55 over 6. Okay. Vishal, same thing.
55 over 6.
You are tired of me. 55 over 6. Now, we are much more intelligent than this, dealing with this problem. So, yes, I will give you guys the opportunity. So, here, this is, it's as simple as that. This is the butterfly method that we always use, right? Whenever you have something like that. So, this is 3 over this. So, this becomes 3 equals 18 times x minus 9. And you know that this is 3, 18 times x is 18x, minus 18 times 9 is 162. And then, so that means 18x equals, this comes to this side, this becomes 3 plus 162, which is 165. So x equals 165 by 18. That's what you guys did. Okay, so this is 55 theta 165. And 18 is 6 times 3, and you did tic-tac-toe, you got 55 over 6. And again, you guys all will be knowing, right? If you have to find out, hello Sarah.
Hi, sir.
And you guys will be knowing that if you have to divide this number, here you see 18, so that is 6 times 3. That is easy to find out. 165, is it divisible by 3? You will add the numbers, 8, 6 plus 5, 11 plus 1, 12. 12 is divisible by 3, that means can be divisible by 3 as well. Okay? Lonil. So that is how you got 55 over 6. Now, this was an icebreaker, okay? I'm going to make the ice little hot. Now, if you have to solve x plus 3 divided by x square plus 9x plus 18. Equal to 7. Can you guys solve it for x? And I'm not trying to teach this to you guys because you know how to deal with rational number, you know how to deal with rational equations, I mean conceptually, and you also know how to deal with quadratic equation as well. So I want you guys to solve it, and there is a hidden agenda behind this question. So that's why I am not trying to teach this to you guys. So once you solve this for x, then I will open my mouth. So you guys have 5 minutes for solving this. Can I assume everybody is trying? Okay. Okay. Sarah, are you trying with her? Dhanushri? Okay. Saranya, Shravya, Thanu, everybody trying, right? Anjani, very quiet. You are trying with Albita? Okay. Try solving it, and then I'll tell you what was the hidden agenda behind this question. Ritika, you got the answer already? You have raised your hand?
Forgot to put my hand down, sorry.
Okay, no worries. Yes, Vishal.
I got negative 41 divided by 7.
X equals negative 41 divided by 7.
Yeah.
And you got only one answer?
Yeah.
Okay.
I
Yes, sir.
got x equals to 13 divided by 14 and x equals to negative 27 divided by 14.
So this is one answer. Second set of answer I'm sharing from there. We kept one more time.
13 over 14
30 over 14.
and negative 27 over 14.
Okay. All right. Any other answer? Yes, Pranit.
41%.
Okay. Anybody else? Anjani, Riya, Shravya, Sarnya.
I'm still working on
Okay. Varun? Yes, Anjani, beta?
I got negative 21.
Okay. Thanu, are you able to give it a shot?
I mean, I kind of understand that.
Sorry, beta?
I kind of understand that.
Okay. Don't worry. I mean, anyways, regardless of how everybody is solving, I will solve it towards the end because I was saying that I have an agenda, right? So I will, anyways, talk about that. But I will solve it in the simplest possible way. I'm just giving everybody some time to give it a shot, and then I will try solving it for you guys. Okay. Vishal, anything else you want to add? You have raised your hand.
No.
Okay, okay. Who's going next? Dhanvin, Dhanushri. Still working on it. And whoever has finished the work, this is your golden opportunity to relook at what you have done. Was there anything that you overlooked? Is there something that you can think differently? Because math is about practice and thinking. So think through what you have done and look at your own story. Yes, Arush.
I got x equals to negative 41%.
Okay. So I have heard enough answers from you guys. So let me look at it as a student, not as a teacher. Now, when I look at this problem, right? Now I need everybody's attention. Okay? So here, when I look at this problem, I will spend few seconds to digest this problem. Right? That is my strategy with run. So when I read this, okay, I have a more like a linear expression here, and I have a quality expression here. If I move this guy, I will have a quality equation. Here, I'll have only x term and some constant. Do I have something common here which I can use for breaking it? X squared plus 9x plus 18. Okay, let me see if I can factorize this. That might make my job a little easier. Let's see. X squared plus 9x plus 18. If I try factorizing this, let's say this is the equation for me. If I try factorizing this, what will happen? X squared. Okay, so this, my A is 1, my C is 18. A times C is 1 into 18, which is 18. How do I factorize it? I can say 1 into 18, 1 into 18, or 2 into 9, or 3 into 6. That's it. Can I pick any of the combination which, if I add or subtract, gives me a B? Yeah, I see an option here. This is my strategy for solving quality equation, right? So 3 and 6, which is a factor of 18, if I add them together, I get a 9. Oh, I got a clue. What I can do is, I can break this into x squared plus 3x plus 6x plus 18 equals 0. Or even if you are not converting to the equation, that's fine. You can still factorize an expression. So here, if I take these two together, what is common here? X. So this becomes x plus 3. And this becomes, here I have 6 common, so this becomes x plus 3. So this whole thing can be factorized as x plus 3 times x plus 6. Is it making sense so far? So I look at this quadratic expression. I'm saying, do I have to wait factorize it? And if I find something common, I can knock it off. My job will become easier. Yeah? Riya, Tanu, Ritika, Praneeth, everybody with me, right? Vishal?
Yeah.
So now, see, you guys are full of energy. I'm getting old. So I am trying to be as lazy as possible. So I became lazy here by looking at this problem, right? And that's my strategy always. I'll read the problem a couple of times to see if I have something that rings the bell for me. So it became x plus 3 into x plus 6. This is my, so this expression can be split into x plus 3 into x plus 6. That is what we saw just now. Equals 7. Okay? So here I can knock out these two guys. What do I have? 1 by x plus 6 equal to 7. Now you have all the ways to simplify. 1 equal to 7 into x plus 6. That became 1 equal to 7x plus 7 6 is 42. Or 7x equals, I'm keeping 7x this side, moving everything that side, became 1 minus 42, which is minus 41. So x equals minus 41 divided by 7, which was the answer given by most of you. Okay. So this was my easy way to solve a problem, and it became easy way because I wanted to make it easy. And how did I make it easy? I stared this problem for 30 seconds. And I struggled with myself in the first go. So those 20 seconds or 30 seconds that I spent here, that is giving me fruit here. Is it making sense to everybody? Anjani, Vishal, Praneeth, Saranya, everybody? Tanu? Arush, Sahib, no worries, right? Is this sounding like a decent approach? Dhanushri? So see, this is the beauty of the most boring concept I keep on insisting about, right? That you need to practice this with every problem that you come across. And more you practice, this will become what do you call a muscle memory, a habit, an attitude, an approach, whatever you call it. And you will see that starts giving you some advantage there. Yeah. Now, this is one part of the solution. Now, I told you guys, right? I have an agenda. But before I move on, is this clear so far? Is it crystal clear so far? Riya, no worries better, right?
Yeah.
Okay. Now I see the problem is I'm not a happy-go-lucky person. I am trying to dig problem in the space where I don't see a problem. See, when you solve it with this approach, you know, okay, I got the answer already. Why I have to muddle the water further? But this benefit in doing that. Here you should look at it. This thing. You have something in the numerator, something in the denominator. You got a perfect answer here. But there is one more call out that you can do. If let's say you had a 0 here, life would have been more interesting. You would have still said, okay, fine, 1 by x plus 6 equal to 0, or let's say you had a 1 here, and you would have said, okay, fine, this cannot be 0, this cannot be 0, it will be undefined state. So you will probably start thinking more about it. But let me not get you confused. Let's stick to the problem here. So I have this expression right now. One thing is very evident, that if you ever come across a situation which says x equal to minus 3, you want to outrightly reject that option. If you ever come to a point where it says x equal to minus 3, you want to outrightly reject this. I mean, that is not our answer right now. We have not derived that as an answer. But here, by looking at this expression, if ever x equals minus 3, then this will become 0, this will become 0, this will be an undefined state. That you don't want to get into. So if you, let's say, if you had 5 options given, or 4 options given for this problem, for solving this problem, x equals minus 3, x equals minus 41 by 7, and then 2 more values. As soon as you came to this point, you will say, okay, fine. When x equals to minus 3, this whole expression becomes undefined. 0 by 0. 0 by 0 is something that I don't want to deal with. Right? I don't want to deal with anything where I have even 5 by 0. Because if I have 0, this becomes infinity. There is no end to it. So I want to knock out the scenarios where I have a 0 in my denominator, regardless whether I have it in the numerator or not. So if you had 4 options, you would want to knock it off. This scenario is an example of extraneous solution. Okay? When you try solving an equation or rational equation or any kind of equation where you come to a point where some value of the variable will give you an undefined or lead you to an undefined state, that is the scenario, that is what is extraneous solution. Okay? Or something that is not fitting in the equation. I mean, if you put minus 3 here in this place, this becomes 0 divided by something here. And you will see that this value doesn't satisfy this condition. So extraneous, whenever you talk about any extraneous solution, these are the solution for the given value of x when you are trying to solve for x, which will sound like a solution, but when you put the value in the equation, you will see that denies the contract. And any equation has no meaning to it if the value of the variable doesn't abide by the contract of the equation. Okay? So I talk about extraneous solution, and you might not be able to digest that right now because you are saying that, sir, why you are talking about it where this is not my solution at all. I'm not even getting to that as a value for x. But I'm just calling it out because when we come to extraneous solution, then you will see merit in what I'm talking about right now. But is this part okay so far? At least the approach that we took for solving a rational equation. Now look at this equation. This is a much more complicated equation than what you will deal with when it comes to rational equation. Let me give you one standard equation or problem that I found in Khan Academy while going through the concept for you guys. And then you will see that whatever you learn or whatever you tried relating just now, is that easy or difficult compared to what you are going to encounter with. 2 equals 11 divided by 4k minus 3. Solve it for k and see which one is the answer. First answer is k equals minus 17 by 8. Second option is k equals minus 8 by 17. Third option is k equals 8 by 17. Fourth option is k equals 17 by 8. You have 4 options here, and this is a typical problem that you will deal with when it comes to rational equation. A sample equation. I am not saying that you will not deal with quadratic equation in the rational equation, but one of the standard ones. I want you guys to solve this and tell me the answer without solving it. Because I want you guys to practice the elimination technique. What is the answer that you guys are leaning towards? and tell me the thought process behind that. Tanu, are you with me, beta?
Kind of.
Kind of?
Yeah. I get it. Yeah.
Oh, okay.
I think it's C.
You think it's C. So I have one vote for C. I will let you speak why you came to that conclusion. Let me get some more answers. Yeah, Praneeth. Say that again. B. Okay. Sahib.
17 over 8 on which option?
17 over 8 is D.
Oh, D, then I got
So it's A is minus 17 over 8, B is 17 over 8. B is, yeah, yeah. So B is minus 8 by 17, C is 8 by 17. Yeah, Dhanvin.
I got D.
You also got D.
I wrote it wrong. It's C.
You also think D. Okay. Vishal.
I got 17 by 8.
So that is D. Okay. Arush, Tanu, Riya,
Oh my God.
Sara, Neil. Yeah, Vishal, you are saying something? Okay. So let me pick some of you. No, that was not the right statement. Let me pick brain of some of you. Okay. Let's see. I'll start with David. Why you think it's D? How do you eliminate other three options?
So it has to have 17 on top because if you look at the 3 and multiply it with 2, no matter what, the 17 will always be on top. Because the 4 and the 2, that'll obviously give you 8, but like you still with K, so like yeah. So
Okay.
that's why I got rid of B and C. And then it can't be negative because you're adding. So,
Yeah.
yeah.
Okay. Tanu, Riya, Praneeth, anybody wants to? Anjani, what is your option here?
I'm sorry. I got D.
You also got D. And so, since I picked your name, beta, tell me how did you come to D without solving it? What went in your mind?
First I was like the process of elimination. So I knew that the picture was like negative, so I got it all sorted out. And then I just solved it.
Okay.
But I got rid of like the negatives because like I just only looked at it and
Right. Okay. Tanu, any thoughts, beta? Whatever you heard from the friends, is that aligning with your approach as well? So here, though I said that no, you have to solve it without solving it, but there's something that goes in the mind, right? I mean, brain doesn't remain empty; it keeps on working. So here, you will always think that okay, this whole thing is going to go up. 2 times 4, 2 times 3 is minus 6. So whenever I'm trying to solve it, this minus 6 will come to this side and will become 17. And here, everything on this side is positive, everything on this side is positive. So negative is not an option at all. You knocked up 2 of the options immediately. And then you saw that, okay, 4 times 2. So whenever I'm trying to make the k go alone, I'll have to get rid of this 4 times 2 thing. So that is going to come in the denominator. 8 is going to come in the denominator and so it has to be positive. So that is how here it's not an option because 8 is in the numerator. So again, while I was explaining it, I probably took 30 seconds, but when you are doing it in your mind, you will probably take much less time. And that's how you all were able to answer very quickly. Now there's a big dilemma that I'm creating for you guys, right? I'm saying that, okay, we all need to get into the habit of solving the problem step by step. And then I'm again misguiding you guys, saying, okay, no. Some problems you have to solve without solving it. So I'm actually navigating you guys towards a point that whenever you have a question, when you are reading it, when you're in the first step, that is the step, or when you're analyzing it, at this step, you have to take a call, whether you are actually going to solve it, whether you need a Nike shoe or not. Okay? Is the problem simple enough to be derived without solving it completely, or you have to still put down the steps one by one? So now I'm kind of demeaning the Nike itself, right? I'm saying that initially I was saying, okay, read the problem, then analyze, then you try doing it. So don't jump onto doing the problem. Now I'm saying that read it, analyze it, and then you take a call whether you have to do it or not. So in any which way, when you have to solve a problem, actually solving the problem is the last step. That is where you will see that when you're trying to solve any equation, any problem, you have to make a lot of judgment. And that judgment will not come by just thinking about it. You'll be able to enhance your ability to judge your approach or derive your approach by doing a lot of practice. So whatever we are doing in the class, that is probably good to get started with the conceptual part of it, but I'm still relying on you guys to make sure that whatever we learn in the class, you solve few problems for sure by yourself alone. Okay? And then keep judging your teacher that, okay, did this old man explain the concept well enough for me to be able to solve the problem? Whatever I learned in the class, am I able to apply that and solve it? Okay? So I'll keep on reiterating that. That might sound a little boring at times, but bear with me, that is the key. Okay? Is that all okay? Are the kids okay with whatever I'm saying? Yeah? Okay. Do you guys feel okay being called kid? No? Sarah, Neil? No remarks? Okay. All right. Okay. So I'll assume that you guys have no problem me calling you kid, and that should be okay. That should be perfectly fine. Let's move on. So let's look at few more problems, but that will not be on rational equation. This time we are going to deal with radical equation. So rational equation is pretty straightforward that way if you look at it, right? I mean, it's just a matter of whether you are dealing with linear equations in the numerator denominator, or you are dealing with multi-equation or expressions in the numerator denominator. And then your first approach or attempt would be to simplify it. Because this might look a little messed up, complicated, but this is not. Here if you look at it, this is a square minus b square, x plus 7 into x minus 7. And this one is, yeah?
I have to go right now somewhere.
Yeah. Sure. You can watch the video. That's where there's more responsibility on your shoulder then after the class. Alright? And this one is nothing but a plus b whole square. My a is x, my b is 7. Look at it carefully. See, this became x plus 7 into x minus 7, a plus b into a minus b, and this is a plus b whole square. So whatever looked in the first go complicated, it becomes much more simplified when you stare the problem. Yeah? Don't stop the problem, stare the problem. Yeah? I know this might not be sounding like a legitimate recommendation coming from an old man, but just get the lighter aspect of it. Okay? So what I'm saying is, whenever you have a problem, problems are made simple or difficult by us. They are simple by themselves. Okay? Somebody, like I'm cooking up these problems on the fly. Imagine somebody like me, somebody as old as me, or somebody little younger than me, or little older than me, might be setting the question, right? It doesn't come from AI or from machine learning. It comes from somebody who wanted to kind of explore what are different ways we are trying to find out to solve a problem. Yeah? Okay. So now let's move on to radical equation one more time, and that is when we will talk about some scenarios with respect to extraneous solution as well. That will be our last thing in this topic. Now let's look at, let me see what are the problems that I have given to you guys yesterday. Let's say I have, this one I think we solved, I will not go through that. 5x plus 3 square root equals k plus x. This is the problem given. Square root of 5x plus 3 equals square root of k plus x. For what value of the constant k, what is the value of k? The given equation has x equal to 2 as the only solution. So I am reading this for you guys one more time. I have a radical equation here which is square root of 5x plus 3 equals square root of k plus x. It says find out for what value of constant k. K is a constant, not a value. This whole equation will have only one solution, that is x equals to 2. Yep. It's 11. Okay. I got an answer already. Before I could finish the problem, David has an answer already. Let's see. Did everybody understand this question?
Yes, sir.
Okay.
I got 11.
You also got 11. Sara, Neil, Shravya, Thanu, Varun, Vishal, Riya. Okay, so let me do one thing. Yep, Varun.
I also got that.
You also got 11. Everybody is becoming good friends. Okay. Arush. Yes, sir. Yeah, Praneet.
11.
You are also at 11. Anybody else who wants to vouch for a different number, different answer? What happened? Sara and Neela are very quiet today. What happened, beta? All good? Okay. Working alright? So, okay, let me do one thing. Let me not bother you very much because I have something more to cover. This question says, this is a radical equation where this is one variable, the other variable, and this is a constant k. The value is not known right now, which we have to find out. And says, solve this equation and find out what is the value of k for which it gives you only one solution, that is x equal to 2. So how would you solve it? You will, okay, you have to keep in mind that your value is x equal to 2. We'll come to that. What we don't like is these radical symbols, right? They are annoying. How do we knock it off? Square it. What it becomes? The square of the square root knocks off the radical symbol here. The square of the square root again knocks off the radical symbol. This becomes k plus x. You get 5x minus x equal to k minus 3. So 4x equal to k minus 3. Now it says for x equal to 2. So you already know the value of x. When you put the value of x equal to 2, it becomes 4 times 2 equal to k minus 3. That means k equals 3 go to that side, becomes 4 into 2 is 8 plus 3, 11. Yeah, and that is how everybody got 11. No problem with this one, right? Is it okay so far? And this is only solution. So this is only solution. There is no confusion about it. Right? Now let's go into some interesting aspect of it. Now let's pick up another problem which makes life little interesting. So here I am picking up the next problem. But before I go so ahead, is everybody on board with this or on the same page? Tanu, Dhanushri, Priya, everybody, right? Okay. And again, I am calling out names because when I don't hear somebody, that just reminds me, okay, let me make sure that I am not leaving any child behind. This is the equation given. This is a radical equation because you have a radical symbol here. Yeah? It says, addition, somebody named Addition, solve the equation below by first squaring both the sides of the equation. So somebody is trying to solve this equation by squaring both the sides of the equation. That means, obviously you know that when you have to knock off the radical sign, you will do a square here, you will do a square here. This guy is not doing anything different. So let me not make it confusing here. This is the question given to us, and other information is that somebody is trying to solve it by squaring both the sides. So I am writing it here. Okay, that's the first information in the equation. In the question, what extraneous solution does addition obtain? Now you guys will start thinking that, okay, what is extraneous solution? Why do we have to derive it? So let me first solve it for you guys, and then I will make you guys practice one of them. Okay? So it says that this is the equation given to us. Somebody is trying to solve it by squaring both the sides, which is fair. It says find out what extraneous solution he finds. Meaning, by solving this thing, there will be value of x, some value of x. Okay, some value of x, which is an extraneous solution. Meaning, you solved it, you found two values of x. When you fit that value of x here, it doesn't work. So it's like a, what do you call it? It's like a boomerang. You had the equation that you solved, you got the answers because you know how to solve it. Now the solution that you got, one of the solutions when you are fitting in that equation, it is not satisfying this point. Hey Kian, you are 10 minutes early for the class. You might want to drop off and join back again so that you don't get stressed out by the difficult problem. Okay, keep down. So it's a very interesting state, right? That you have an equation, you tried solving it, you got answers. When you try fitting in those answers in the equation, it doesn't work. Let's look at it. So here, now somebody took this radical equation, squared it. So this approach looks fine to me. So let's continue with this. So square of this equal to square of this. So that is fine. Square of this is basically a minus b whole square. So this becomes a squared. So a is my 2x, so 4x squared minus 2ab. So 2 into 2, 4x, and b is 1. So 4x. And plus b squared, that is 1, equals, this whole thing square root getting squared becomes 8 minus x. Yep. What do you get here? 4x squared minus 4x plus 1, moving over to this side, okay? Minus 8, and this minus x becomes plus x, equal to 0. Yep. Now, apples together, oranges together. So this becomes 4x squared minus 4x plus x, that is minus 3x. 1 minus 8 becomes minus 7. This is my equation. I want to solve this equation to get the possible values of x, right? Is everybody with me so far? Yeah? Okay. Now, when you solve this, so we know how to solve it, right? Let's not worry too much about the things. We have a very fancy formula that's called quadratic formula. So here, what is my A? A is 4. What is my B? B is minus 3. What is my C? Minus 7. The quadratic formula says that the partial values of x will be equal to minus b plus minus b squared minus 4ac by 2a. I'm assuming everybody is aware of the quadratic formula that we use for solving a quadratic equation, right? Yeah. Sanu, you would have come across this before, right? I mean, since you are new to this class, I have not taught this to you for sure, but I'm just curious to make sure that you have come across this before, right? I'm sorry, Vitra? Yeah, okay. No, I'm just trying to make sure that if I'm teaching something, you should not think that, okay, this gentleman is talking gibberish, okay? Okay. So now, I'm fitting in the value in this quadratic formula to get the value of x. So here my b is minus 3, so minus of minus 3 plus minus b square. B square is minus 3 square is 9 minus 4 ac. So 4 into a 16 into c is minus 3 by 2a. My a is 4. So I got x equals minus into minus plus 3 plus minus, in bracket I have 9 plus 16 theta 18. Sorry, 16 theta 48. 48 plus 9. So this becomes positive. So this became 16 theta 48 plus 9. 48 plus 9 is how much? 57. Divided by 2 times 4 is 8. Did I miss something? No.
Wait, you put B instead of C for 4AC.
4 is C.
Put negative 3
Yeah,
instead.
that's why I was thinking, why not taking a purchase square kind of scenario? Okay? Yeah, thank you. So b square minus 3 square is 9 minus 4a. 4 into 4 is 16 into c is minus 7. So now, yeah, this might help me make my life a little easier. That's why I'm thinking, how do I get a square root of 57? So here, this became x equals minus plus 3 plus minus, let's find out this value. 16 times 7. 16 times 7 is 112 plus 9 is 121. The square root of that. 9 plus 9 plus 112 is 121. Square root of that is 11. 11 times 11 is 121. Okay. So this became 3 plus minus 11 divided by 2 into 4 is 8. So here I am talking about two answers of x. One when I am taking plus, so 3 plus 11 is 12. 11 plus 3 is 14 by 8. 14 by 8 or 7 by 4. And second one is 3 minus 11, which is minus 8. Minus 8 by 8. That is minus 1. Okay. So we got two values of x. One is 7 by 4. Second one is minus 1. Is everybody with me so far? Yeah? Danvin, Dhanushri, Sara, Neen, everybody, right? Okay. So now, by doing whatever we wanted to do, we got two values here. Now let's try fitting in these values in the original equation and see what happens. When I put x equal to 7 by 4, so that is, let's put minus 1 first, that will be easier, right? 2x minus 1 equal to square root of x minus 8. Sorry, 8 minus x. In this equation, when I put x equal to minus 1, that means 2 into minus 1 equal to 8 minus x. 8 minus x is minus 1. So this became 8 plus 1, 9. Square root of 9 is 3. So this became minus 2 into minus 1 plus 2 minus 1 equals 2 into minus 1. So this is minus 2 and you have minus 1 here. So minus 3 became equal to square root of 9. So minus 3 equal to 3. Does it sound right by any chance?
Isn't it plus or minus 3?
You have plus and minus 3, agreed. But then 1 is still not right, right?
Yeah.
Equal to 3. When you reach square root of 9, you get a plus 3 or you get a minus 3.
Yeah.
When you are getting a minus 3, that one is matching. When you are getting a plus 3, it's not matching, right? That is what is extraneous solution. Meaning you solve the problem, you got the solution, but you yourself are not convinced about that being the right solution.
So like it used to, like it could be plugged in, but it's not correct.
It's not correct. It's not abiding by the contract of this equation. Is that making sense to you all? Yeah? So, in summary, I will see again, this is very simple and straightforward, okay? Extraneous solution is a scenario when you have a solution by solving a problem in the most legitimate way, but once you got to the solution, when you fit in that value, it's not working. It's like 2 plus 2 is 4, and then you are saying, okay, 2 plus 2 is minus 4. And everything, okay? And you will find this problem more when you are dealing with square root scenario, when you have even number of power, be it in the numerator or denominator, okay? When you are dealing with a odd power, it's perfectly fine. It doesn't bother. Okay? So, I would want you guys to, I mean, I have myself put few more questions in the WhatsApp group. Pick up the ones that we have not touched with the radical equation and try solving it and see if you are getting any scenario of extraneous solution or not. Conceptually, it's very straightforward. You pick a problem, solve it, got the answer, fit the value and see are you convinced. If you are not convinced, if it's not abiding by the contract, there is a problem that needs to be fixed. Yeah? With that being said, I will let you guys go. Enjoy the rest of your evening.